The Improbable Ape, a journey through the astronomical odds of human existence, by Rob Corley. Written and produced by Rob Corley. The Cosmic Blueprint. So you won the lottery. What's the prize? What kind of universe did you just inherit? To answer that, we have to pull back, way out to the very fabric of reality itself. Because your improbable existence didn't happen in just any universe. It happened in this one, a cosmos so exquisitely, absurdly fine-tuned for life that it makes your personal lottery win look like a sure bet. Picture this. 13.8 billion years ago, in the first fraction of a second after the Big Bang, the fundamental laws of physics were being written. Not by some cosmic author, but by the universe itself, settling into the patterns that would govern everything that followed. And in that moment, briefer than a heartbeat, smaller than an atom, the universe made a series of choices that would determine whether it would become a sterile wasteland or a cosmos capable of producing stars, planets, and eventually, you. The universe chose well, almost impossibly well, the cosmic control panel. Imagine a control panel with dozens of dials, each governing a fundamental aspect of reality. The strength of gravity, the charge of an electron, the mass of a proton, the rate of cosmic expansion. Each dial has to be set to precisely the right value, not close, not approximately, but exactly right, for the universe to work. This isn't science fiction. This is the reality physicists have discovered over the past century. The universe is governed by a handful of fundamental constants, and every single one of them appears to be balanced on a knife's edge. Take the strong nuclear force, the cosmic glue that holds atomic nuclei together. If this force were just 2% weaker, protons and neutrons wouldn't stick together. The only element in the universe would be hydrogen. No carbon, no oxygen, no iron, no chemistry, no life. If it were 2% stronger, protons would fuse so readily that all the hydrogen in the early universe would have been consumed in the first few minutes after the Big Bang, leaving no fuel for stars. 2%. That's the margin between a universe full of possibilities and a universe that's essentially dead on arrival. Or consider the electromagnetic force, which governs how atoms interact and how chemistry unfolds. Make it slightly stronger, and electrons would be held too tightly to their nuclei, preventing the formation of molecules. Make it weaker, and electrons would escape their orbits entirely, leaving behind a universe of unstable atoms incapable of forming anything complex. But perhaps the most mind-bending example is the cosmological constant, the mysterious force driving the accelerating expansion of the universe. Physicists have calculated that for galaxies to form, for stars to ignite, for planets to coalesce, this constant must be fine-tuned to an accuracy of 1 part in 10 to the 120 power. Let me put that number in perspective. If you wrote it out, it would be a 1 followed by 120 zeros. That's more precise than hitting a target the size of a single atom from a distance of 14 billion light-years. It's like balancing a pencil on its point, not just for a second, but for the entire age of the universe. And yet, here we are. The Goldilocks universe. This isn't just about 1 or 2 lucky breaks. The universe had to get dozens of these fundamental parameters exactly right. The ratio of matter to antimatter, the initial expansion rate, the density of dark energy, the mass difference between protons and neutrons. Each one represents another layer of improbability, another cosmic dice roll that had to come up exactly right. Scientists call this the fine-tuning problem, and it's one of the deepest mysteries in physics. As the late physicist Freeman Dyson put it, the more I examine the universe and the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. This doesn't mean the universe was designed for us. That's a leap of faith, not science. But it does force us to confront the sheer improbability of our existence. We're not just lucky to be on the right planet, in the right solar system, in the right part of the galaxy. We're lucky to be in a universe that allows for planets, stars, and galaxies to exist in the first place. Think about it this way. If you were to randomly dial in values for all the fundamental constants of physics, the probability of getting a universe capable of supporting life would be effectively zero. You'd be more likely to win every lottery on Earth simultaneously while being struck by lightning and discovering a new species of dinosaur in your backyard. And yet, against all odds, the universe rolled the dice and came up with exactly the combination needed for complexity, chemistry, and consciousness to emerge. The galactic sweet spot. But even in a universe fine-tuned for life, not all neighborhoods are created equal. Just as Earth sits in the habitable zone around our Sun, not too hot, not too cold, our entire solar system sits in what astronomers call the galactic habitable zone. Picture the Milky Way as a vast cosmic city. At its heart lies a supermassive black hole, Sagittarius A star, surrounded by a dense cluster of ancient stars. This galactic downtown is a violent, chaotic place where radiation levels would sterilize any emerging life, and gravitational forces could fling planets out of their orbits like cosmic pinballs. Move too far out toward the galactic suburbs, and you encounter a different problem: cosmic poverty. The outer regions of the galaxy are starved of heavy elements, what astronomers call metals, meaning anything heavier than hydrogen and helium. These elements, forged in the hearts of earlier generations of stars and scattered through supernova explosions, are the essential building blocks of rocky planets and life itself. Carbon, oxygen, nitrogen, iron, the stuff of our bodies, is rare in the galactic frontier. But there's a sweet spot, a ring-shaped region about 27,000 light-years from the galactic center, where conditions are just right. Not too violent, not too calm. Not too metal-rich, not too metal-poor. This is where our solar system has made its home for the past 4.5 billion years, orbiting the galactic center in a relatively quiet spiral arm called the Orion Spur. For billions of years, our sun has navigated this cosmic river, avoiding the treacherous rapids of the inner galaxy and the barren emptiness of the outer rim. That stability, that long, unbroken peace, gave life on Earth the time it needed to take hold, to evolve, to diversify, and eventually to produce beings capable of looking up at the stars and wondering why they exist. The anthropic paradox. This brings us to one of the most profound puzzles in science, the anthropic principle. For centuries, science has been guided by the Copernican principle, the idea that we don't occupy a special or privileged position in the universe. Earth isn't the center of the cosmos. We aren't the pinnacle of creation. And yet, the evidence for cosmic fine-tuning seems to suggest exactly the opposite. Our existence appears to depend on a remarkable confluence of improbable conditions. We find ourselves in a universe that seems almost tailor-made for life. The weak anthropic principle offers one way to resolve this paradox. It states that we observe the universe to have life-friendly properties because if it didn't, we wouldn't be here to observe it. It's a selection effect. Of all the possible universes, we could only have evolved in one that had the right conditions for life. It's like asking why you were born in a hospital rather than on Mars. The answer isn't that hospitals are cosmically special. It's that you couldn't have been born anywhere else and survived to ask the question. But this raises an even deeper question. If our universe is so improbable, how did we get so lucky? The multiverse solution. One answer that's gained traction among physicists is the multiverse hypothesis. What if our universe isn't unique? What if it's just one of an infinite number of universes, each with different physical laws and constants? In such a scenario, the apparent fine-tuning of our universe becomes less miraculous. It's like a cosmic lottery where trillions upon trillions of tickets are sold. Most universes would be sterile, their constants set to values that prevent the formation of stars, planets, or life. But in a multiverse of infinite possibilities, some universes would inevitably win the jackpot. We're simply the inhabitants of one of those winning tickets. There are several theoretical frameworks that could give rise to a multiverse. Inflationary cosmology suggests that the rapid expansion of the early universe didn't stop everywhere simultaneously. Instead, it continues indefinitely in some regions, constantly spawning new pocket universes with potentially different physical laws. String theory, with its extra dimensions and multiple possible configurations, could also give rise to a vast landscape of different universes. The multiverse hypothesis is speculative. We may never be able to directly observe other universes, but it offers an elegant solution to the fine-tuning problem. If there are enough universes out there, then finding ourselves in one that supports life becomes not just possible, but inevitable. The cosmic perspective. Whether our universe is a one-off miracle or just one of many in a vast multiverse, the conclusion remains the same. The conditions for our existence are extraordinarily rare. You are not just improbable, you are a walking, talking, thinking testament to the universe's capacity for the extraordinary. Consider what had to happen for you to be reading these words. The universe had to begin with exactly the right expansion rate, not so fast that matter couldn't clump together, not so slow that it would collapse back on itself. The fundamental forces had to be calibrated with impossible precision. The first stars had to form, live, and die, cooking up the heavy elements in their nuclear furnaces and scattering them through space in spectacular supernova explosions. Our galaxy had to form in just the right way, with our solar system ending up in the perfect cosmic neighborhood. The sun had to be the right type of star, not too big, not too small, not too variable. Earth had to form at just the right distance, with just the right composition, protected by just the right magnetic field. And that's before we even get to the biological improbabilities, the emergence of life from non-life, the evolution of complex cells, the development of multicellular organisms, the rise of intelligence and consciousness. You are the product of a chain of cosmic coincidences so unlikely that they approach the impossible. You are made of star stuff, forged in the hearts of dying suns, assembled by gravity and chemistry into a pattern complex enough to contemplate its own existence. You are the universe becoming aware of itself. You are 13.8 billion years of cosmic evolution, opening its eyes and looking around in wonder. The prize revealed. So what's the prize for winning the cosmic lottery? What did you inherit when you beat odds that make winning every earthly lottery simultaneously look like a sure thing? You inherited a universe of infinite possibility, a cosmos where matter can organize itself into galaxies and stars, where chemistry can give rise to biology, where evolution can produce consciousness. You inherited a reality where the laws of physics allow for complexity to emerge from simplicity, where the dance of atoms can create symphonies and sonnets, where stardust can contemplate the stars. You inherited a universe that not only permits life, but seems almost eager to create it. A cosmos where, given enough time and the right conditions, dead matter can wake up and wonder why it exists. But your cosmic inheritance comes with a catch. This fine-tuned universe that made your existence possible also made it fragile. The same delicate balance of forces that allows for stars and planets also means that small changes can have catastrophic consequences. The same cosmic processes that created the elements of life also created the potential for its destruction. You've inherited a universe that's both incredibly robust, it's been running for nearly 14 billion years, and incredibly delicate. A universe where the margin for error is vanishingly small, where the difference between existence and non-existence can be measured in decimal places. This is your cosmic context, the stage upon which your personal improbability plays out. But here's the thing about discovering you live in a fine-tuned universe. It's humbling. And humans haven't always been good at humility when it comes to our place in the cosmos. For most of human history, we thought we were the center of everything. We built our understanding of the universe around the assumption that we were special, that everything revolved around us, literally. It took centuries of scientific discovery to teach us otherwise, to show us that we're not the center of the universe, but something far more interesting. We're the universe's way of understanding itself. But that's a story for another chapter.